Today, I talked to Tony Roberts, the founder and lead developer of a company called Pixel, which produces an Excel add-in that allows users to integrate custom Python tools into Excel. In our conversation today, we talk about why a finance professional might want to learn Python instead of any other tool. And particularly, we talk about the characteristics that distinguish Python from similar tools like R, MATLAB, and Tableau. So if that sounds interesting to you, you're welcome to join us. Maybe to start, it would be good if you could give a summary of Pixel and a little bit of your background, just for anybody who's watching, to give them context.
Sure. Yeah. So, and we talked about this before, but for everyone else listening, I started Pixel or PyXLL. It's actually going to be 15 years ago next week, I think. So it's kind of amazing, like how long I've been doing this. But what it is a Python add-in for Excel. And my background, sort of prior to that, was working in financial services, writing Python code primarily for front office applications, so trading applications, applications for researchers, analysts, all that kind of stuff. As well as I worked for a relatively small hedge fund, doing kind of front to back stuff. And what I found coming into finance very quickly was just how much work is done in Excel. Prior to finance, I was working in video games where very little is done in Excel. A lot more is done in assembly than in Excel. But coming into finance, it really struck me how so much of people's day-to-day work happens in Excel. And so in this team, we were building applications for traders and all these kinds of things. And every time we would deliver some new piece of functionality, a very common thing that people would ask was they'd say, okay, yeah, this is great, but how do I get this into Excel? And there was just no good answer for that. Sure, with Python, you can very easily write Excel reports, you can write Excel files, you can read Excel files and get the numbers in and run stuff and put it in a database or vice versa. But for actually having that interactive tools in Excel, so you can actually have a trader sit down and say, okay, I want to price up some portfolio, or I want to pull data from a risk database and run some stress scenarios, that kind of thing. If your underlying models and your underlying systems are written in Python, at the time there was no good way of exposing those directly to Excel. And so I spent a bit of time sort of cobbling stuff together using Excel has a COM API. So I did loads of stuff using COM in Python, which was pretty mature at the time, to kind of bridge that gap. And that worked, reasonably well for a sort of ad hoc, sticking plaster, if you like. But even having done all that, I really felt there was this missing piece, which was being able to write an Excel add-in like you can in C++, but just directly in Python. And so that was really the sort of the seed of the idea for Pixel. And so, 15 years ago, plus or minus, I wrote the kind of the first initial version of Pixel, which very simply just let you write Python code, sort of like a simple Python function, and then with a decorator, tell this Pixel add-in that I want that Python function to be callable from Excel. So, you could have the sort of typical example I give is if you have a Black-Scholes model written in Python, you just add this Excel func decorator to it, load the Pixel add-in into Excel, and then suddenly you can do equals Black-Scholes or whatever your function is in Excel.
And could you explain what a decorator is?
Yeah, sorry, of course. So Python's a pretty rich language. That's one of the reasons I like it so much. Is it's really good for beginners to be able to get into. For lots of people, it's their first experience of learning a programming language, but it also has a huge amount of depth. And decorators is one of those things that kind of comes into that depth thing. In essence, really a decorator, as a user, all you need to know is that it's just a little bit of thing, like some text that you add as a prefix to a function to annotate it, to say, this function is not just a function, it's also something else. Kind of going a bit deeper, what the decorator actually is a way of hooking into Python to be able to modify the function. It's really, when you decorate a function, your decorator has access to that function, and then it can return a new function, or it can return the same function with some changes, or it can do nothing. But it's like a hook in Python that lets your code hook into that function that's being called. I'm not sure I've really explained that very well.
Well, I'm curious because I've never done anything like this before. I haven't worked with decorators before.
Okay.
Why is it necessary for you to use decorators in order to call Python functions from an Excel add-in?
So maybe an easier way to kind of explain what a decorator is, and then I think I can explain the next bit a bit better, is to explain another common use case of decorators. So if you have a logging framework where, for example, or a metrics framework where you want to see like how often a function's being called, this kind of thing, you might write your functions just as you do normally, but then you might say for functions A, B, and C, you want to write something to the log file saying, function A starting, function A finishing, that kind of thing. It's a very sort of simple logging thing. Rather than making changes to your function to add those print statements at the beginning and end of your function, what you can do is write a decorator which says, print function X starting, call the function, and then print something ending. And then without making any changes to your original function, all you have to do is add that decorator before the function, and then that functionality kind of envelops your actual function.
So you're saying a decorator allows me to add functionality around my function that is then executed. Anytime I call my function, it's not necessary for me to put a decorator in a function call.
Precisely. Yeah,
okay.
Exactly.
So
there's a little bit more to it than that, but that's a way that you can use decorators, yes.
And then how does that connect to the XL add-in?
So the way that the decorator works in Pixel is you add this decorator to your function, to the beginning. So you're not modifying your function itself, you're just decorating it to say, don't change this function, but include it in the Pixel add-in. But what that decorator does internally is when that decorator is run, it then just kind of like notes that, okay, yeah, the user wants this function to be called. And so internally what it does is it adds it to a registry of functions. And then when as part of the XL add-in being initialized, it can then see like all the functions in that registry that it's remembered because these modules have been imported and the decorators have run. And so then it can set up the bindings from native XL functions to the Python functions so that the sort of magic happens when you say equals my Python function in Excel. The add-in then knows, okay, yeah, this function is bound to this Python function through that decorator.
Okay. Well, I could understand that at a more deeply technical level, but that's probably something I should do on my own. I'm curious, and I know this must be a common question for you, and we talked about it a little bit on our last call, but what do you think about Microsoft's Python for Excel, and how would you compare that with the experience of using Pixel?
Yeah, no, I think that's something that comes up more and more now, and I think it's a little while since we spoke about this, and obviously Microsoft's solution has moved on. I think when we spoke before, it was just in preview, whereas now it's publicly available. So it's a good time to kind of catch up on that again. And also, having seen how people are using it now, it's kind of clearer to me the different use cases where some people use one and some people use the other. But essentially, although they sound very similar, they're actually two very, very different solutions. So Pixel, as I kind of alluded to, is this add-in that gets loaded into Excel, which then allows you to call Python functions sort of seamlessly from Excel. So Pixel
functions
on the one
defined
hand,
separately.
Exactly, yeah. So Pixel on the one hand is this tool for building Excel add-ins that you can write in Python and then have an Excel user who knows nothing about Python. To them, these functions just look and behave exactly like native functions. And there's, aside from like just worksheet functions and macros things, there's a whole load of other stuff around user interface and ribbons, and we can go into that later. But the Python in Excel, the Microsoft solution, on the other hand, is kind of very different in the way that it works. And rather than actually embedding Python into Excel, what they've done is given you this new function, this equals py function, which takes a whole load of Python code that you write in a cell in Excel, and then sends that Python code off to an Azure server, sort of in the cloud, and then it runs that Python code against a sandboxed Anaconda Python environment, and then the result comes back, and then the result is kind of displayed in Excel. So technically they're very different, but what that also means that in
Could I interject with a quick question?
Yeah, of course.
When you execute a function that is that you have access to through Pixel, are you using local compute?
Yeah. So what's actually happening there? And again, this goes back to at the beginning, we were talking about my experience in finance originally, and there it's like super critical that spreadsheets work fast. You don't get very far in finance if you're building spreadsheets that take minutes or hours to calculate, because people just don't tolerate it. So from the outset, Pixel was designed to run as fast as possible. So the way it works is it actually embeds the Python runtime directly into the Excel process, which means that everything is running locally in your actual Excel process. So
okay, so not even just locally, but within the Excel program.
Yeah, so it's not even like a separate process that's running and talking to Excel. It's actually like, at a technical level, it's in the same process. So what that means is you have access to, it's running your local Python with all of your local packages installed, which also means any kind of extension modules you've got built or any packages you're using, you can import and use those, with no issues at all, because it is just your local Python. But it also means you have access to all of your local resources, so file system, networks, databases, all that kind of stuff. It's not like...
Which you don't with Python and Excel.
Yeah.
Because it's that your code is being executed in that Azure Anaconda environment, which is isolated from your local files, right?
That's correct, yeah. But also the thing with running it locally is that means there's like the absolute minimum time between your values in Excel being run, them coming into Python, your Python code running and getting the results back, because it's all in process, so it's all instantaneous. Whereas with the Microsoft Python in Excel, it's sending your code and your data across to an Azure server, running in the sandboxed environment, which only has the packages that Microsoft have kind of blessed and put there, and has no internet access, no access to your local file system, no access to your databases, all that kind of stuff. So, it sounds very, very limiting. And when you try it, you see it does become very, very slow, especially like if you have more complex sheets, that time really adds up and you get quite clunky spreadsheets.
Although Microsoft will charge you for faster compute.
Yeah, they will. But you can have as fast compute as you want, but you're never going to get like that speed of networking between your computer and some Azure system. Even if you have gigabit Ethernet between the two, it's never going to be as fast as as having the actual data in process already. And it's kind of instantaneous because you don't even have any inter-process communication because it's all in the same process. Getting back to kind of the use cases of like why you would use one versus the other, I very much see what I've kind of seen already is that people who've never used Python before and have maybe been a bit kind of scared to install it themselves are now able to open up an Excel workbook and then start writing some Python code, and then, or more frequently use like Copilot or ChatGPT to generate some Python code, and then run that in Excel and then see the results. So the use case for like individual analysts with no or little Python experience, being able to run some Python code via Excel is quite compelling. But what I'm seeing is that people are kind of doing that as an introduction and then hitting these roadblocks and then saying, well, actually, I don't always want to be writing code in Excel. I want to be developing actual packages, actual more robust Python code that I can test and develop outside of Excel and then bring it into Excel. And then that's where kind of Pixel comes in.
That's nice. Yeah. So Python in Excel gives users easy access. Everybody has Excel on their computer. So now everybody has a Python development environment. But then it is limiting. It's not a nice development environment either.
No, I mean, they're making efforts to make it nicer. Like they added the advanced formula editor, which gives you kind of more, sort of code highlighting and things like that. But I think as well as that, for me, one of the disadvantages is the fact that the Python code is then just saved in the workbook. I remember kind of years ago when I was working, in finance with these huge spreadsheets that relied on, way too much VBA. And what happened on more than one occasion is, one of the traders or whatever would say, "Oh, the spreadsheet's not working. Can you take a look?" And I'd go and take a look, and sure enough, there was, some issue with some VBA code. I spend a while debugging it and fix it, and then, they're good to go again. But then the same day, someone else on the same desk is like, "Oh, I've got the same problem." And then so you go from desk to desk, like copy paste, because this VBA code isn't just like in one shared workbook. It's a module or something that's been copied and pasted across multiple different workbooks.
Maybe with some edits.
And just these, these bugs, or these, not even bugs, just like, things change, right? So sometimes a function needs to change because of some market convention or whatever it is. But the code just kind of like moves like a virus through all of these different Excel files. And I see the same happening with Python if you allow Python to be saved into your workbooks. And particularly, if the main use case is for inexperienced new Python developers, that's, to me, seems like a recipe for disaster for large enterprises to allow that to happen. Whereas kind of Pixel, on the other hand, was always done from the other point of view, which is that Python code is code. It's written by developers, or can be written by non-developers who know how to write Python code as well. But the point is, it's written in tools like VS Code or PyCharm or whatever it is, checked into Git or whatever version control systems you're using, tested, goes through continuous integration, continuous deployment, that kind of stuff. And that's how you build Python software. And then Excel is really just the user interface layer onto that Python software, rather than being everything, rather than being like your code repository, your testing framework, all of that stuff. So I guess it's kind of highlights a difference in viewpoint from, me wanting to build sort of robust, solid Python tools that can then be deployed to Excel users versus the use case of, I guess, kind of someone who's Python curious but doesn't have Python installed and wants to just like try writing a few little bits of Python.
What you've just done between Pixel and Microsoft's Python and Excel is what I would like to do between Python and alternatives. And I've been working on that recently, trying to compare Python to things like SQL, VBA, R, MATLAB, and so on. I showed you we did this research looking at job postings, and we pulled out tools which were commonly mentioned alongside Python, including the ones that I just mentioned and a few others. And the question that we're asking is, why should any finance professional learn Python specifically? Like, I'd like to know, is there anybody in the world who has some problem where Python is the best available solution? Nothing else can do as good of a job as Python. And if so, who is that person? And what exactly is that problem? And what characteristics of Python make it best suited to solve that problem? And as I've dug into that, I've realized it's a more complex question than I expected, because there's a significant amount of overlap. Like, I still don't consider myself an expert in Python. I'm learning new stuff all the time. I'm learning about decorators today. I'm definitely not an expert in R. I'm definitely not an expert in MATLAB. And so my ability to compare the functionality of these different languages is limited. But from afar, it seems to me like a lot of what you can do, if not almost everything that you can do in Python, you can also do in both R and MATLAB, and largely in VBA when you're talking about automating things in spreadsheets, although there are many things that you can't do in VBA that you can do in MATLAB, R, and Python. And yet, when I look at the GitHub data, it tells me their Octaverse report I was recently looking at, there are over 2 million active Python developers on GitHub, whereas there are only 100,000 active R developers and even fewer MATLAB developers. So if the functionality is so similar, why is Python so much more popular? Is it because its syntax is that much more intuitive. When I look at examples without having much experience in MATLAB or R, they both seem like high-level programming languages that are relatively intuitive to learn, similar to Python. So I'm trying to forthrightly, honestly regard the situation, not advocate for my tool because it's the one that I get paid to teach, and understand what the real differences are. So I'm curious if you can help me to understand the distinctions between these technologies and also the specific problems that Python's well suited to solve based on your experience.
Yeah, so I think the thing that really struck me when I first started using Python, and I think one of the reasons it's become so popular is because it's such a good sort of integrating language.
Mm-hmm.
And
Guido calls it glue language.
Yeah, yeah, but kind of more than that, what I found is that it's set up so nicely to be able to write kind of extension modules. And so you're saying, is Python the best language for X, Y, or Z? And arguably, like, no. In many cases, it's not. Like, if you want to write super high performance financial quant models, like, Python is not the language to do that in.
You're probably using C++.
You'll be using C++, or you might be using Rust, or or even like Java, for example. But most likely, quant, you're going to be using C++. But what Python does, like above that, is it makes it really, really easy for you to integrate that into a Python library. So you can have like a super fast quant library written in C++ and then have Python bindings on top of that, so that you can then give it to an application developer, someone who's developing overnight reports, somebody who's developing a website, whatever it is, so they can have like a really nice Python API that has all the power and flexibility of your like super fast C++ library.
Okay.
And so that's kind of like Python is this great layer of kind of bringing everyone together. So you don't not everyone has to like always work in exactly the same language. You can go deep into like the specifics of what you want, but Python is like this layer that means that everyone can meet there. And when it comes to just sequencing things together, it doesn't necessarily matter that Python isn't the fastest language in the world when you have all of the bits that are underpinning it being incredibly fast, because that's where you spend most of the time. And actually, calling those bits from Python takes like no time at all. And so that's true of C++, but it's also true of like, SQL was another one that you mentioned. And when you're building applications, it's actually kind of pretty rare, I think, that you write raw SQL, but you don't write it like in a SQL editor. Or certainly by the time you're getting it into production, it wouldn't be written in that way. More likely it's written using some kind of sort of SQL generator, like SQL Alchemy, something like that, where you're writing expressions which then get turned into something that the database can understand and execute. So you're using SQL, you have to have an awareness of SQL, you have to understand how databases work well to use that, but you can kind of orchestrate it all in Python much more easily than having just like some horrific long string and then calling db execute in in an old C library, which is kind of how it was done decades ago. And I think pretty much like any of those other technologies that we're talking about, they all have Python bindings, and so Python's just become its success has really come about because of having all of these different bindings to all of these different things. So it's become the de facto language in lots of different industries, and I think that's a large part of why.
So Python is a sort of meeting place. It provides a common interface. If you need something that Python doesn't provide, for example, the performance of a lower level language like C++ or Rust, you can use that language to develop the tool you need and then call it through Python. For some reason, R and MATLAB are not that meeting place, and I wonder if there's a technical reason for that. I can imagine cultural reasons for that, like historical reasons. One thing I've been thinking about recently is the history of a language affects the culture of its community, and it affects the packages that community develops. It affects the way that the language is used. I know from the little bit of research that I've done that MATLAB seems to be used more commonly by scientists and researchers. R does have a presence in finance, but seems to be more commonly used in academia and by statisticians, like academic statisticians. Whereas the Python user base is more diverse, not as concentrated. Yeah.
I think there's definitely, like, history has a lot to do with it. And I was going to kind of add that as well as the being able to call different languages, it's really the ecosystem of packages that makes Python so appealing. And you definitely have that to an extent with R and MATLAB. Like, there's no doubt, there's some great R packages. But if you look over time, like if I go back, I don't know, maybe to 2010, that kind of time, people were using Python, but we had packages like NumPy and SciPy back then. So for doing numerical analysis and things like that, we had good tools for doing that. But for doing things like time series analysis, for like forecasting, things like that, it was all much more complicated. So you could have NumPy arrays and you could do stuff on that, but it was never quite as nice as doing things in R. So R always had this concept of data frames, and that's why people like statisticians
native. You didn't have to import pandas.
So the pandas didn't exist.
Okay.
So this is why I was saying kind of history has something to play here. And if you look at the split between R and Python in certain areas of finance, like particularly in research and algorithmic trading, things like that, I think back in, maybe it's not 2010, I might have these numbers wrong, but around then, you might have seen more of a split towards R, where people were using R more. And when pandas kind of first appeared, there was a few other like things floating around at the same time to do with like named sort of column stores, that kind of stuff based on NumPy. But pandas was developed over a few years, sort of relatively quickly, to fill that gap, making Python more kind of feature complete in that regard compared to what R had. And I think that was like a big turning point for when some of these finance companies started to take Python a bit more seriously and started to realize that, they can, move to Python and have the advantages of having all of these other existing packages, like NumPy and SciPy and things that people were developing, and being able to much more easily call into or call native libraries than with R, where with R, it really was kind of people who are heavily into stats and people doing time series analysis, like, understood R very well. But outside of that, it didn't have all the things like the sort of easier access to the web technologies and text process. Like anyone who's listening to this who knows R really well will be screaming at me, because I'm sure R does have all of those things.
Well, if they know Python really well, they're already screaming at me.
Yeah. But I'm sure R does have all those things, but for whatever reason, like those other areas of development, kind of Python was already ahead of R in terms of number of users and things like that. So people started to look at that and say, okay, well, if Python's already great in all these areas and it's just missing these few bits that R has, then with pandas or with other similar libraries, that gap starts to close, and then people from the R camp start to come over to the Python camp.
And go ahead.
I was just going to say MATLAB's kind of different again, because both MATLAB and R, you can write C extensions. That's no problem. Like, that's no different from Python, really. It's just certain aspects of Python make it, I would argue that it's much easier to write a C extension for Python than it is for R or for MATLAB. And again, like MATLAB and R users will be screaming at me saying it's much easier in their languages. So I accept that. But with MATLAB, I think one thing is it was very, very popular in universities and academia and things like that, and certain branches of science. But the fact that it's only available as a commercially licensed application, I think, is probably what's held back some of the adoption. But then there's been efforts with some of the things that are great with MATLAB, like the actual interactive environment for scientists that you get with MATLAB and also RStudio, have kind of fed into what's now Jupyter Notebooks and other similar projects. So there's been attempts from the community in different aspects to kind of look at like the best things of all these different products and then bring those into Python. And as Python's kind of gained in popularity, the interest in these other tools has also gained, and it's kind of been this feedback loop where the Python tooling's been getting better and better, and Python adoption has been getting higher and higher.
And that becomes a virtuous cycle. the larger the community is, the more productive they are. And so the more packages we have and the better they are, at least at the top end. It has seemed to me like package availability might be the number one differentiator between Python, R, and MATLAB. I was just looking at the stats, so I've got them fresh in my mind. R has 22,000 packages on CRAN. MATLAB, you can buy 62 produced by MathWorks for $45 a pop. They also have, what's the repository? MATLAB file sharing or something like that. There are 50,000 community packages. So twice as many as R. But you have over 600,000 packages on PyFi for Python. And not only are there 2 million Python developers active on GitHub compared to 100,000 R developers and like 50,000, I don't know, less MATLAB developers, the number of Python developers is growing something like 22% a year, has been for the last 4 years, whereas R is growing at 5% and MATLAB is growing at 3%. So there's a big difference in the size of the developer community of each language today, and that distance will probably increase in the future if the trend continues.
I think one thing that Python's done really well, like since the first version, is kind of how it can appeal to new programmers. Like it's relatively easy for someone with no programming experience to go through a few tutorials or a few courses online and start writing some Python code. And I would kind of argue that the same is not so true for R and for MATLAB. And I think part of that is with Python, it's what they sort of call a multi-paradigm language. So if you go to university and study computer science, if you did this, several years ago, you would have had some professors who were all just like object-oriented programming. That's like the only thing. And then you're learning Java. But that's not so easy for a beginner. Whereas if you were doing it 50 years ago, you'd have been learning like Sinclair Basic or something like that, which is super easy for a beginner. You just say, 10, print, Tony is cool, 20, go to 10. And, that was pretty much my first program I ever wrote. And to do the same thing in Python, without the line numbers and the go-tos, to write a while loop to do the same thing is just as easy, because you have this imperative programming style that you can use in Python straight away. You don't have to start having, we weren't talking about Java, but to compare it to Java, there's a lot more boilerplate that you have to do to do that kind of main function. You have to have, all these classes, and there's just a lot more stuff you have to understand before you can start doing stuff. Whereas with Python, you can start doing stuff at the same time as learning about like how all these other things fit together. And then once you've decided that object-oriented programming, that's what you want to do, you can start to do bits of that in Python as well. If you decide, actually, I'm super interested in functional programming, you can do aspects of functional programming directly in Python as well. So it's this really interesting thing where it's not one thing or the other with Python. It's got all of these different aspects. And so it's a really, really good language for starting to learn, but also as you learn, it kind of has more and more and more until you sort of, you think you're this Python expert, and then you'll be reading the release notes of the next version, or some obscure bit of docs, you'll be like, oh, I never knew it did that. And you find more bits that, you can go even deeper into.
Or OpenAI releases a package and now you need to go learn that.
Yeah.
So I'd like to talk to you about programming paradigms. I'd also like to talk to you about abstraction, like interface abstraction, and also how that relates to the scope of utility of a tool. I want to show you a chart. Let me see. I'm new to this platform that we're using, so let me see if I can figure out how to share my screen and also pull this file up. And you're welcome to critique this. I'm not sure that I've gotten it exactly right.
I'm just worried from what you were saying, you're going to ask me stuff that I should know from a CS degree many years ago, and I'll just have no idea what you're talking about.
Well, I'm just figuring this out. This is just me thinking things through. I'm just hoping we can put our heads together. All right, so I've got my file up. Now let me see if I can share my screen. As I was thinking about how to differentiate Python from its alternatives, these are the top 10. by the way, except for C++. That the number 10 most frequently mentioned alternative is Cognos, which is now an IBM tool. But I put C++ was in position 11, and I decided to bring it in so that I would have a lower level programming language. So I was thinking about how to compare these tools. And as I was looking at different characteristics, I started to realize that everything I was noticing, most of what I was noticing, grouped into two categories. Number one, interface abstraction, and number two, scope of utility. When I say interface abstraction, I mean Tableau, which we have right here in the top left. Can you see my mouse?
Mm-hmm. Yeah.
Yeah, cool. So Tableau up here in the top left is designed to help users easily develop interactive dashboards. So I can visualize data, I can send it to my boss can click things and explore the data without needing much technical knowledge. Mm-hmm. And dashboard itself, well, users interface with dashboard almost exclusively through a graphical interface. In some situations, users can write formulas similar to Excel's formula language, mm-hmm. which is I think we could classify that as a high-level programming language.
Yep.
But for the most part, there's from what I understand, as somebody who's not a Tableau user, Tableau users don't use that very often. Most of their work in the program is done through a graphical interface. Then you have Excel, which does provide a graphical interface, but users spend a large part, if not the majority of their time in Excel writing formulas. Basically a high-level programming language. Then you have VBA, where there is basically no graphical interface. You're just writing a high-level programming language. And then you have Python. I put Python, R, MATLAB, VBA, and SQL all basically in the same category as a high-level programming language. I'm sure that you could differentiate these more finely across the level of abstraction, but I'm not familiar enough with them to do that. And then C++ is a lower-level language. So I started charting these out and thinking about how generally these tools are useful. Tableau is just good for interactive dashboarding. I could do interactive dashboarding with Python, and I can do a lot of other things. Excel is good for manipulating tabular data. I can do that in Python. I can also do a lot of other stuff. As I put these logos on this chart, I realized that they form a diagonal line. And I thought that makes sense. I would prefer to have a high-level graphical interface, all else equal. It's simpler, it's visual, it's more intuitive than having to learn like C++ syntax. So why would anybody learn C++ syntax? Only if it allows you to do something that you can't do in Tableau. Like, I could make Tableau in C++, I could make Tableau in Python, but it would take me a long time. I could also send Salesforce $1,400 a year, and they give me this nice interface, and I don't have to learn all of that stuff, which would take me enough time that I'm saving more than $1,400 a year if that's all I need to use it for. So that's what I mean when I say abstraction and scope of utility. And you're talking about things that you have to write in a Python program that aren't necessary in Python. Am I right? Are those the two things you were comparing, or am I getting confused?
Sorry, so things that you write?
Well, you're saying something like, I can write a Python program to accomplish what I can accomplish in Java more simply.
Yes.
There are more syntactic elements that I have to include when I'm writing.
I was saying that in relation to learning to program. Like there's less that you have to, there's less boilerplate, there's less things you have to understand to get started.
It seems to me like there's a line, like there's an efficient frontier of scope of utility and interface abstraction. So I don't know Java, but it seems to me like there's like one of two things must be the case. Case number one, Java requires users to include these syntactic elements because they cause the Java runtime to configure things differently. Like if you include different syntactic elements, Java will configure the program, or it'll configure things differently. It'll execute different operations. And so those syntactic elements give you a lower level of control, which is sometimes useful.
I think in some cases, it's not necessarily a lower level of control or a higher level. It's just a different way of expressing the same thing. So they've made different kind of linguistic choices or different language choices to do the same things.
Okay, so
what's kind of interesting, I think, about the things that you've put on this chart are, if we zoom out a little bit and think about the types of users that use these different things. And in some cases, when I say users, like one person can be two users. They can be a developer and an analyst at the same time. Because things like Tableau, Power BI, things like that, very much in my mind sit in that area of being, they're used by a consumer, someone who wants to see a dashboard, infer some results from that, or whatever it is. And then behind the scenes, you might have someone who's configuring it. So that's like a sort of a front-end tool to underlying databases. Like Tableau doesn't exist on its own. It needs data sources. It needs like ETL things to get stuff into it. The same with Power BI and those other things. And Excel as well, I think, sits in that camp because, lots of people use Excel and lots of people write formulas, lots of people write VBA in Excel. But then many more people actually just consume Excel reports. They'll be sent an Excel report, or there'll be one on a shared drive, which they'll open periodically, and they use it just to look at results, or they use it just to have like a calculator that someone else has built, and they go in there and they know that if they update, number in cell C3, then the result in some other cell, works. So they're kind of consumers of that report.
I see.
But then on the other side of the line are kind of the underpinnings of all of these things. So, if you're working purely in Excel, you might have an Excel application that is powered by some VBA code. Or if you're working in Power BI, you might have the Power BI application that has some some SQL databases kind of underneath it. And I think what's really interesting with the flexibility of Python and how Python can be made to interact with lots of different platforms is that, especially a shameless sort of plug, but with something like Pixel, you can have Excel still there sitting as your front end. So you can have your sort of high level sort of users working in Excel, running models, doing scenario analysis, that kind of stuff. But with the actual Excel model itself, calling into code written in Python, where your Python code is your quant models or whatever it is, but you're just using Excel as the kind of the visual layer. And to go sort of deeper into that, you can have Excel being the visual layer to some Python code, which has been written by whoever that is. Could be the same person who's using the Excel report. But then that Python code that they're writing itself might call in deeper into some C++ stuff.
Yep.
So, if you use machine learning...
In which case, the Python developer is the consumer.
Yeah. So, if you were to use any of the AI tools at the moment, or, if you were to have like an LLM thing sort of running in Python, chances are that thing isn't going to be implemented entirely in Python. It's going to be implemented in C++, or maybe it's using like some GPU stuff using CUDA or whatever it is. But you can then just use that from Python, which is like your sort of comfort language.
Yes.
But in the same way, if that Python code is then exposed to Excel, then an Excel user can sit there in their sort of like zone of comfort, being able to build Excel applications, but with all of that kind of stuff underpinning it.
We can descend into lower level interfaces. That requires us to deal with more complexity. And we do that because we gain something. We gain some utility. We wouldn't deal with the complexity if it didn't benefit us somehow. There are certain technologies at different levels of with interfaces at different levels of abstraction, which have become popular. And there are other technologies which are much less popular. And I wonder if one factor, maybe a major factor in the success of a technology, is whether or not it rests upon the efficient frontier of the trade-off between abstraction and scope of utility.
Yeah, no, I see what you're saying exactly. And I think that's probably true. But I think probably where that trade-off is very sort of industry and application specific.
Okay.
So as another example, just to throw another language in there, Fortran probably didn't appear on your list because no one in finance or no one that's using Excel is going to be writing Fortran code.
Yeah, I think it was literally the language at the bottom of the GitHub data.
But if you're if you're a research scientist and you're running code on supercomputers, chances are you're going to be spending a lot of time writing Fortran code because Fortran is like extremely well suited for a certain class of problems which those types of people want to be able to solve. So for them, writing routines in Fortran is kind of natural, and that gives them that advantage. But then as you go up that stack of abstraction, if you've got someone who's wanting to do some numerical analysis, say, that relies on some of these other algorithms, they're not necessarily going to want to write their entire application in Fortran. To give it like a more concrete example, if you wanted to build a website that was doing some calculation, so you could have, anyone can come to your website, put some numbers in, run some computations, and gets the results back. You're not going to write your entire web application in Fortran, or Fortran users listening to this will be screaming at me now, saying you can, but trust me, like most web developers aren't going to be writing that in Fortran. But what you get is the ability to call from Python code into your Fortran library, where your Fortran library can be written by people who are super competent in Fortran, and they've chosen that as their sort of weapon of choice in dealing with this very specific mathematical problem. So I think that trade-off of like where it makes sense to use one language versus another is going to be very different depending on application, and also probably experience and environment of the team that are building it, because you're not necessarily going to get people that have been using Fortran for the last 20 years to start writing another language because they're so used to using one tool. And that's coming back to the thing of why Python has become so popular as like this glue language that just sits on top of all of these other technologies, making them accessible to kind of the next level of abstraction.
Mm-hmm. Yeah, so you describe it, I guess the way that you described it made me think of it as a meeting place of developers and consumers, I guess is one way to put it. A marketplace even. And for some reason, it's an especially popular one. I see what you're saying about Fortran being particularly useful to people in a specific domain. So it's not right to say lower level equals more generally useful. But what I do see is that popular low-level languages do, at least the ones that I've, or maybe I shouldn't say popular low-level languages, popular software, if I can include languages as software, appears to rest on this efficient frontier. And so that if I have this diagonal line, over here I have highly abstract software like Tableau, or software with a highly abstract interface that is useful for a particular purpose. And then down here I have C++, which is generally useful, or Python, which is like more generally useful than Tableau. If I descend below that line, then I could potentially use a higher level interface to accomplish the same job, except for the fact that I'm hiding a dimension in the map that I showed you, which is this map. I'm attempting to map these tools across scope, the dimension of scope of utility with scope of I'm using the term scope of utility to refer to the absolute magnitude of the scope of utility. But there's also the question of where exactly is this useful? Like I might have a tool, one tool which is generally useful and another tool which is generally useful, but they're generally useful in different domains.
I think another thing to consider is kind of like time to value, if you like. So if you're a portfolio manager and you need like some information on a daily basis, then do you get the most time to value from looking at a Tableau dashboard that's being put together that you can just open and you might like fiddle around and select some different things and do some filtering or whatever it is that way? Or do you get more time to value sitting down and writing, some Python code that goes and queries some databases and fetches it and puts it into like pandas or polars and doing all this kind of stuff? And I think probably what's often true is that the sort of things you've identified as higher level, more specific, give those users like a lower time to value.
Mm-hmm.
So you can do everything in Python, or you can do everything in C++ or whatever it is. But in order for someone whose skill set is portfolio management and not being a software developer, their time is probably better spent in a more in a tool that's more like custom built for them, rather than
because I can spend somebody else's time to develop the dashboards that I need. I don't have to spend my time doing that. But that dashboard doesn't exist unless somebody's developing the dashboard, somebody who's more technically proficient in Tableau than maybe the portfolio manager consumer. And then that Tableau software doesn't exist unless it's developed in,
I guess you have like different layers of this, right? Where you have, obviously you can build all of the dashboards that you need using Python. And that's what lots and lots of companies do using technologies like Dash. But lots of companies don't, want to invest all of that time and effort in building dashboards using those lower level technologies. So they'll take an off-the-shelf solution like Tableau or Power BI or whatever it is, and then spend less time customizing it to get what they need. Mm-hmm. Whereas someone who goes down the route of building it in Python might get something that to them is of higher value because it more specifically caters to exactly what they want.
Yes.
But the trade-off is they have to spend more time building it and customizing it.
Which is like somebody who buys a car and is willing to like install upgrades to their engine and modify the suspension. Like most buyers, most car consumers don't open up the hood and tinker with their engine. But some people want performance and they are willing to invest the time to gain that lower level understanding so that they can customize their car to meet their needs better.
And also it's different use cases and different requirements. You could buy a Ferrari or you could buy a Renault 5 or something like that, and both will get you from A to B. But which one is more useful for going down to the supermarket to get your weekly shopping, and which one is more useful, if you're going to a track race? Mm-hmm. Right. And it's not to say that one car is better than the other, although I guess maybe a Ferrari versus a Renault 5 is not good in that example. But what I'm saying is that whether one's better than the other kind of depends on exactly what you want for a specific task.
Right. So each car has a different scope of utility. We could say that the less expensive, the more normal car is more generally useful than the Ferrari, but in its domain of utility, the Ferrari wins hands down, which is sort of like Fortran in the example that you were giving. And so I don't know if we'll be able to answer this question on this call, but the question that I'm asking is why, what exactly is the sweet spot that Python has hit? Why is it that this particular level of abstraction, this particular scope of utility, which is general, it's meeting some need? And it seems to be meeting it better than things that appear quite similar, like R and MATLAB. And we can say maybe it's the things we've already talked about, like the libraries. You compare the syntax to Java, but I'm not sure. And the reason why I want to know that is because PyFi needs to market our classes. I have finance professionals who are maybe wondering, should I learn R? Should I learn MATLAB? Because in the job postings that we look at, some of them, maybe not the majority, but a significant portion of them say things like, you need to know Python or R or MATLAB. Okay, so I'd like to get this job. Which one should I learn?
I think coming back to the reason as to why Python has been successful in that role of the general purpose programming language. Really does just come down to what we were talking about earlier with the range of packages available and the kind of, I guess, the few things where the range of packages available, the kind of the beginner friendliness, as well as the depth of what it can do, and also its sort of role as an integrator of all of these things, and where it kind of where it differs from, I guess, what I always say to people who are looking at learning Python is, if you're thinking about you want to solve a particular problem, and you start going, okay, well, I'll write some code to do this, that, or the other. The first thing you should always do is just search to see if there's a package that exists for that already.
Yeah. Don't reinvent
chances
the wheel.
are, like, there is, and it's just that huge breadth of what's available means that you can be so much more productive, kind of standing on the shoulders of all these other people that have already built these packages. And a lot of the times, if you're in some really, really niche area, then you may find that a package exists, but it isn't like exactly what you want, or it doesn't, it's missing some feature. But most of these Python communities are also pretty friendly, and in a way that I think I've not really seen it so much in other language communities. I think Python communities tend to be a lot more embracing of new people. And so if you find a package which doesn't do exactly what you want, or you have some issues with it, then if you kind of engage with a community that maintains that module, then more often than not, you'll find kind of like-minded, enthusiastic people that you can engage with and actually work together with to, get what you want in Python. And the same may be true in R and C++ and stuff. It's just, I haven't had that experience of it. Okay. But with Python, it does seem to have this sort of friendly environment around it.
Finance professionals have higher level tools like Tableau, Power BI, Excel, Alteryx, and so on. I want to understand, why do different kinds of finance professionals need a lower level solution? Like, why would a finance professional ever bother learning Python instead of sticking with Excel and other tools like that? I know that it's not right for everybody. I'd like to know, who are the people who would benefit from that, and why exactly would they benefit? And you've been working with finance professionals who use Python much longer than I have. So I'm interested to know your thoughts. But maybe before we go into that, I can quickly review the data that I sent to you. We looked at 2,700 job postings. I guess I can show you that. We looked at 2,700 job postings. About 10% of those mentioned Python. All of these job postings were in finance-related categories from financial institutions, private equity firms, also companies like Toyota or Procter & Gamble. So we looked at all kinds of companies, more finance companies than not, and found that Python was mentioned most frequently in jobs posted by investment managers, 39%. Second most frequently by banks. Only 6% of private equity jobs mentioned Python, and then 3% of other companies. And then AQR mentioned it most frequently. Not surprising, since that's where Wes McKinney was when he created Pandas.
That's right. Yeah.
So they're Python users.
They were in our shop until then.
Interesting. But it looks like the conversion has persisted.
Yeah.
BlackRock, Toyota, Fidelity, JP Morgan is big into Python. They have been for several years. That's a strategic move for them. Apollo is the most consistent Python user out of the private equity firms.
It's nice. I'm seeing lots of my customers in these lists.
Okay, makes sense. So we also looked at the demand for Python in postings of different job types. I sent this to you already. So investment portfolio management was number one, then risk management, research, trading, treasury, although the sample size is small, so take that with a grain of salt. Trading support. Most of these are asset management roles. So what you would expect from the prior stats. And then when we started looking at specific job postings, like breaking down more detail, I think the most interesting insights are out of the job postings that indicated how Python would be used, 70% mentioned data analysis, 27% mentioned modeling. And just so you know, if somebody mentioned modeling, we flagged data analysis. Also, if somebody mentioned machine learning, we flagged data analysis. Automation was mentioned in 18%, 15% mentioned working with large data sets. And I think that we could reasonably group all of these uses into the categories of one, analysis, and two, automation. Seems like those are the two reasons generally why people use Python. I'm going to analyze data, or I want to automate some process. Maybe I want to automate some data analysis. And then I have some tables breaking down those uses by type of company, by type of job, if you're interested in seeing those. And then I have the alternative tools, which are mentioned most frequently. And then these ones are the ones that you saw mapped out. So that's what we have. And I'm trying to figure out who uses Python and why. Like, what are the problems that Python solves better than any alternative tool? I'm curious to know your thoughts about that.
I think it's kind of it's funny to me that you're proposing that question, but while showing me a Jupyter notebook, because I could turn it around to you and say, you've done all of that analysis and all of that free-form data that you've acquired from different sources. So you could have taken all that data and put it into a SQL database and then put a Tableau dashboard on top of it and got the same results out of that. But you didn't. You chose to have it in an Excel file, read it into Python, and do some analysis directly in a Jupyter notebook. So, what was it about that workflow that made you think, oh, that's the way I'm going to do it, rather than another way?
Good question. Although I don't know that the answer will satisfy you. This is the second easiest way for me to analyze this data. I was an investment banker for 3 years, so I'm very good at Excel. But I'm now in a position where I'm responsible for teaching people how to use Python. And so when I went to analyze this data, I thought I should take my own medicine. I probably could have done this analysis more quickly in Excel.
Okay.
But I chose to do it in Python just for discipline.
For fun.
Yeah.
Because I think, not to kind of skip past Excel for now, we can come back to that. But I think for me, the advantage of doing what you've just done in Python rather than doing it in like a dashboarding tool is the fact that you can iterate and get to results very, very quickly. So it's almost like there's different types of Python development, just to kind of make this clear. There's there's building foundational tools and toolkits and things like that, and there's like sort of scratchpad,
interactive,
interactive computation like what you've done. So we're talking definitely about that second, like interactive scratchpad type stuff now. So using Python, you can very quickly.
That's a good distinction.
You can very quickly get some data, do some transforms, get some results out, and when stuff doesn't work, you just change it and do something else until you kind of narrow into that solution. So for those types of one-off ad hoc analysis type things, exactly the same kind of things you might have used Excel for, you can do those very easily in Python.
Mm-hmm.
Whereas using a higher level tool, you can kind of get to the same result in a more polished, more presentable way, but it requires a few more steps along the way. So in your analysis, for example, if you were going to do this, if you wanted to see how this was changing every day, and you wanted to come into your office and see a nice big TV screen, and you could say, okay, well, how's this looking today? Then you wouldn't want a Jupyter notebook where you're hitting Shift Enter on every cell and remembering the order in which you need to do it and all of that kind of stuff. Then you would take what you've prototyped in your Jupyter notebook and then kind of decompose that and then put it into a dashboard, or you might build a dash app or something on top of what you've already done in Python. So it's kind of different use cases. And I think what you're seeing through the job postings is the types of roles where you've got analysts or you've got researchers who are doing a lot of this ad hoc calculation, or they're doing a lot of interactive computation to find out new things, or to if you've got researchers who are wanting to investigate different signals generated from different sort of inputs to their models, and they want to do that kind of like backtesting research, those types of things where they're doing different things all the time, then having a general purpose language like Python that also has really good support for time series analysis and all these other things is like a really, really nice fit compared to building the entire thing as like some some super specific application that answers that one question. You don't need to spend all that time building that application because you can just do that work in Python. And then once you've arrived on that solution, if it's something that you want to be repeatable and reusable and ingestible by non-Python developers, you then take that next step of like taking what you've done and building it into an application, in whatever technology you want at that stage.
Okay, that makes sense. If I'm exploring data, I'm not going to do that in Tableau. I'm going to do it in some other tool. Why use Python instead of Excel?
I think this is like a cultural thing as well. And lots of people, like you say, their default will be to go to Excel. And probably what you're seeing in like private equity, for example, is they use Excel like extremely heavily. So they will do, virtually all of their sort of deal making will be done in Excel. So they could do that in Python, but they just have in that industry the kind of the expertise and stuff built up of doing that in Excel. And I think what we're seeing in a lot of other things like the investment banks that was on your in your data there, and the asset managers, is a shift to doing more stuff in Python, because there's certain advantages. Whereas all that data that you had there, you could have done it in Excel, but by doing that in Python, you could work more easily on larger sets of data. And also there's certain things with the data transformation which just become easier once you start using a language like Python rather than doing it in Excel. For example, one thing that you often see in Excel, and this is there's lots of new things you can do in Excel with the sort of dynamic arrays and the sort of newer style stuff. So I'm not talking about that so much. I'm talking about how the sort of 99% of people use Excel. You start off with one sheet full of data. You might filter it down, or you might do some transformations on it, and then you end up with a second sheet with kind of a bunch of derived data, and then a third sheet and a fourth sheet. And so you might imagine you're doing this for, let's just say like equities, for example. Let's say you build a spreadsheet which does some time series analysis based on one equity. But then you want to take that and you want to say, okay, well, actually, I've done it on A, now I want to do it on B. What do? You take the sheet you've done and you copy it, and then you change the ticker and you change the prices and all that kind of stuff. And then let's say you've got 10 symbols and you want to do some final step, portfolio optimization, whatever it is, or some crossover analysis. You then have a final sheet which takes all of those 10 sheets and munges them together into a final result. So that's all great. But then what happens when you want to add the 11th one? Not only do you have to add an 11th sheet, you have to go and change like all of your final output sheet, because you've written it with the assumption that you get this column here, this column here, this column here. Suddenly you have to go in, and everywhere you've made that assumption, you have to add the references on the new sheet.
You'd have to add a 13th sheet to act as a layer of abstraction, and maybe you'd write a VBA program to insert your row in between the other rows so that your reference range captures the new one.
Yeah. And that's not to say you can't do all of these things. And I've seen spreadsheets in the past where people have like VBA macros where they have like a bunch of sort of hyperparameters, if you like, and they run a VBA macro and it generates the sheet with all of these things in. Whereas in Python, I suppose at the most basic level, you have a for loop that does
right.
This.
With a list of tickers. Yeah.
And that's kind of,
okay.
I always like to sort of think of Excel as being, that's kind of an example of something it's really bad at. But what it's really good at is that sort of first step where you have that exploratory thing of just saying, okay, I want to get this data and I want to apply this function to it. And this, where you're not into that complexity of having n different sheets and then something at the end where you're doing some n by n computation. And that's where pushing that complexity down into something like Python makes sense, because then you can have, I said for loops, but it could equally be like some, matrix transformation or whatever it is. By pushing that complexity down into Python, but then exposing it back to Excel
Mm-hmm.
means that you can have like much sort of high level functionality, but from an Excel user, all they have to know is that they can call like this function to say, call this, and then it's calling all of that more complex stuff behind the scenes. So Excel is still really useful as like this interactive sandbox where you can use it as a scratchpad to say, okay, pull in some data from this, call this function on this data, compose things in an interactive way, but without hitting those limitations of having to write a VBA macro to add a sheet for every step of the computation, because you're doing something that just doesn't really fit with a 2D grid of cells.
Mm-hmm. I think that you're onto something, and I wonder if we can define that distinction more precisely, or define that problem more precisely. So you're describing a situation where, for example, I'm performing some kind of back testing. Is that what you had in mind? I'm performing.
I don't know if it was back
or a
testing
time
in
series
mind,
analysis.
Yeah. So, maybe think for like a concrete example, which is this was sort of years ago working on a corporate real estate sort of cash flow model, if you like. And this model was entirely Excel, and it just had a table of cash flows for each property. So you get rent coming in, and you got interest payments going out, this kind of thing. And then there was a sheet for each property. And so you want to know, like, okay, do some analysis of like, what's my net cash flow, for example, for the next 5 years based on some assumptions for these end properties. But then you want to add a new property in, or you want to say, do that same analysis, but only for properties more than 10 floors, or only for properties in the southeast of England, that kind of thing.
Okay, so people sometimes use Excel sheets. This is going to be rough. I'm just trying to work through it to see if we can pin this down. People sometimes use sheets as modules. Well, I mean, they are modules, but people sometimes repeat functionality across sheets. Did you have
almost like I was going to say in like a sort of, in programming, we might have a function which takes a bunch of inputs and produces an output. And sometimes I've certainly seen it where people use Excel where they use a sheet as not just the function, but they use it as the function bound to some inputs and some outputs.
Yes.
So they have not only like all of the table
it's
of
a
inputs,
function application,
but all of the logic is in that sheet. And so if you want to have a separate invocation of that same function, but with different inputs, rather than just reusing that function, they have to like clone the entire thing.
So I'm wondering, is there not a way to define a function and call it? And I know that there is a way. Excel recently introduced the Lambda function, but most people aren't going to use that.
But it's a question of, so yeah, you have Lambda functions, and you also have, you've always had VBA functions and things like that. But it's often the case that when you have an Excel model, it isn't just one function. You don't have one function that takes all of these inputs and does everything, because you have multiple stages in the middle. So your model might be saying, okay, take these different cash flows, add 10% sum or whatever it is, and then generate like a bunch of stressed cash flows. And then you might have a next stage which says, okay, now filter these cash flows somehow, or whatever it is, do something with them. And then you have like all these stages to your model, and it's only at the very end where you get the actual output. So you don't want the entire model in one function, but because you want those stages to be like visible.
Right. Which is a benefit of Excel. Excel makes your operations visible. You spread it out.
Yeah. But once you've identified like what those stages are, then if you want to kind of duplicate your model with a different set of inputs, you're then still copying and pasting that entire sheet with that whole model down there. And so if you want to make a change to like one bit in the middle, then you're then having to do that across every different sheet, and it becomes much harder to reason about. So I guess there you could say, yeah, you could write like a Lambda function and or this kind of stuff for all of your like intermediate model steps. But as you say, how many people are actually kind of doing that now, other than the, sort of real Excel enthusiasts?
Well, and if you are doing that, it must be equally as complex as Python, if not more,
If not
and
more
the
so,
interface
yeah.
is not as friendly.
Yeah.
If you're doing something that complex, I think you're onto something.
But it also comes down to that point of, we were saying about the ecosystem of Python having all of these different packages, but the same is true in an enterprise. You have hundreds of developers, like thousands of analysts, and so to have them all write that same Lambda function, that might solve like a problem in Excel, but it doesn't solve the problem of, okay, the firm says our standard way of calculating X is this. So you don't have everyone writing the same formula into Excel, because then, how do you verify that everyone's actually using the same calculation?
Or what if you make a change?
Or what if you make a change? Or what if, I guess the example I was giving before is if you're calling into, underlying quant models or whatever, you want to kind of have all of those functions at a high level be available to all of the people that need them. And this is why, traditionally people have written Excel add-ins in C++ or .NET to give people those high-level toolkit type functions that mean that you no longer have to do absolutely everything in Excel. And that's now what you can do with Pixel as well, is building those high-level functions, but in Python, calling into your either the ecosystem with other Python packages or your own Python modules.
Python allows users to abstract functionality so that they can call functions multiple times in a simpler way and modify functions and apply those modifications automatically without having to go through sheet to sheet.
I think all the things we're talking about are all different abstraction layers, and where each kind of where each user and their application and domain sort of finds that sweet spot. Because Python is really, you could view Python as an abstraction on top of C.
Yes.
And you could view C as an abstraction on top of assembly, and you could view assembly as an abstraction on top of machine code, and then machine code is an abstraction on how your actual computer works, which is an abstraction on top. You can kind of go all the way down until
right. Yeah, like
you're not
even
going to be
we're talking about molecules, that's just an abstraction that the physicists give to us because we don't understand quantum.
Precisely, exactly. And it's just a case of finding like that sweet spot of where the abstraction meets where the need is, like what.
Yes, right. And as we move up and down, I think we're moving across that efficient frontier. And yeah, it seems like Excel, what is it?
Okay. If we go back to your Jupyter notebook that you had a while ago.
Yeah, you want to see it? Or
sure, bring it up. Yeah, why not? But I was just thinking on each sort of cell of that. I'll just wait for you to bring it up.
All right.
Yeah. So here you've got a cell that's what's this doing? So this is showing us the number of like alternative tools listed per whatever it is.
Right.
So you've got that as like a cell of computation where your inputs are defined in the cell above and your out and the result is shown in the cell below. So if this was your job in an enterprise to look at this table of things or do something related to this, and there was many of you all needing that unit of functionality, which is to get that, given some input data, to get that output table of things that have been grouped by and sorted and summed and that kind of stuff. You could either have a Jupyter notebook with that snippet of code where someone sends it to you and then you can copy and paste it into your own Jupyter notebook, and then with some comments that helpfully say create a variable called df above with these columns, or they give you a Python package which includes a function which says generate table X. Having a Python package with that function that says generate table X is arguably a better way to distribute that unit of functionality than just a snippet which has assumptions about what's above and below it and all that kind of stuff.
It's
I think
simpler to
sounds true.
understand, simpler to use. There's less possibility of user error. You're not going to go in and mess up the code. But then the downside is that you can't modify it unless you
Yeah.
descend to that lower level.
So that's the downside, and also in some cases the advantage. Because the advantage of not being able to modify it is that then you're consistent with everyone else in the firm that's doing the same thing. And the same is true if you were to do the same analysis in Excel. You could have all of that data in Excel and you could do the same sort of stuff that you've done in there. But if you were doing that all the time and someone said, okay, pushed out to your Excel is now a function which is generate table X, and all you need to do is call it given your inputs, then that gives you that high level tool that you need to work efficiently, but in a way that's just underpinned by some sort of trusted computation. Excuse me.
Okay, well, that's helpful, and it gives me something to think about. And we have another half hour on the calendar. We don't have to use all of it, but I feel pretty satisfied with our conversation on that point, unless you had anything else that you wanted to add. I'm wondering if you have any other thoughts related to distinguishing Python from alternative tools and the kinds of problems that it solves for finance professionals.
Yeah, I think I was just, as we took that break, I was thinking about the tools that you had kind of identified as in those job postings. And I was wondering how many of those were listing Python as like, or maybe they weren't identifying the listings, but how many like actually want Python as the primary thing, but then are saying that, you're going to be writing Python in this role, but it'll be really helpful if you also know SQL, or if you also know Excel, or if you also know R, that kind of thing, because of Python's role as that like integrator of all of these things.
20% mentioned Python exclusively. And in that 20%, I'm including like an AQR job that said, Python is necessary, C++ is a plus. And then 80% list Python in a list of alternatives. And they might have done that intending to say that you will be using Python as well as these other tools, but they didn't phrase it in a way that made that obvious.
I think what's also interesting about if these are like developer roles or roles where some developer experience is kind of expected.
None of these are. These are specifically finance roles. Like they're looking for people
not
with
developers
finance degrees, finance experience.
Because what I was wondering was how many are kind of taking the assumption that like, yeah, if you've spent like a number of years writing MATLAB code, or if you've been writing R code, then you won't find learning Python that hard. So if you're like a really good, really solid like R user, R developer, then come to us with that experience. The finance experience is what's important, and you can pick up the Python that you need like pretty quickly.
I think that might be the case in many situations.
And I think, yeah, I mean, maybe that's one of the key advantages for these companies is, as we said, Python is like a language that's very easy to get started with. And it's also a language that's pretty easy to read. Like if you have some well-written Python code, you can reason about it with relatively little knowledge about the language. And I can definitely see that some companies will see that as a big plus. And that's in a way that's not so true about languages like C++, for example.
Or maybe Java.
Yeah, I guess Java sits somewhere between the two, but in my experience of Java, there is a lot more there's a lot more frameworky type stuff that's helpful to know to be able to write useful Java.
I'd like to know what you think about large language models and AI, because this technology produces more human-like responses to text and images than any form of AI we've previously developed. And on one hand, that's exciting. It seems like we should be able to use this technology to automate some things that we previously didn't think were automatable. For example, I hired a research assistant to help me gather this job posting data. I said, go to the job websites of JP Morgan and Goldman Sachs and so on, and search for jobs that specifically target finance professionals. Here's how you know that they're a finance professional. It requires a finance degree or like this kind of finance experience. And when you get that, extract data and put it in this spreadsheet, and then take a screenshot and put it in the Google Drive. And it was frustrating because my assistant often got things wrong. Like I gave him very specific instructions, and he either added job postings which didn't belong, or he didn't get the data right, like made like typos that are easily avoidable. And so I ended up spending a lot of time reviewing his work, so much that I probably didn't save that much time versus just gathering the data myself. Then I got a premium OpenAI account, ChatGPT account, and I used their agent and gave the agent actually less precise instructions. And the agent did the exact same job, and it got the data with no typos.
I think it's, the reason I laughed when you asked that is because it is one of those things where it is like there are certain things that you can do with AI today that are incredibly useful, but it's still in other ways very, very limited. And I give you as a kind of example of that, I get an email probably, maybe not once a day, but like a few a week, people saying, oh, I asked ChatGPT to generate me this code and it doesn't work. Why is that? And I'm like,
why don't you ask ChatGPT?
Yeah, it's like, because it's generated you the wrong code, because it's generated absolute nonsense.
Yeah.
And so there's like a real danger that people, just think that it's this magic thing that can just generate perfect code that just works. And they don't have the skills to be able to like drill in and see if what it's doing is correct. And so I'm all for people using, AI tools to assist them writing their code. But what I kind of think is this danger is people just blindly following it.
Yes.
Because, in these examples where there's people emailing me saying, oh, this code isn't working, like how many other people are generating code that looks like it works, but is actually not doing exactly what they thought it would. And this was maybe like 6 months ago now or something. So I have, as part of the subscription system that I use, it maintains a list of all of the European VAT rates. So very sort of boring thing that you have to do like as part of your accounting is, make sure that you file correct VAT returns. So I thought, okay, well, I'll just check that this table is up to date and everything. And rather than go through each one, I just pasted it into ChatGPT and said, can you verify these EU VAT rates for me? Goes off, comes back and says, here are all the ones that are wrong. And so I picked the first one that it says wrong, and then I just Google what it is, and it turns out that VAT rate had changed kind of at the beginning of the year. So ChatGPT's like data was out of date, and that's understandable because it has cut-offs and all this kind of stuff. And so I said to it, oh, this one changed on this date. Like, please, can you revise the table? And it's like, oh yes, of course. Like this changed on this date. Repeating what I've said back to me. Here's your new table. And that new table didn't have just one change. It had like a bunch of other changes. And what I found is the more you kind of say like, oh, this is wrong, the more it will come back saying, oh, I'm sorry about that. Here's something else with even more mistakes. And it's almost like if it doesn't get the answer right the first time, then you just end up in this rabbit hole of fighting with it.
That's interesting.
And I think it's, where we are at the moment is you kind of have to take what it tells you with a pinch of salt. And if it gives you the right answer, then that's great. Like, go ahead and use that, but always like question it and accept that it is limited. So in your case, where you're asking it to pull in all this data, then, it sounds like you'd already kind of been through that exercise to a certain extent. So you knew what to expect and you knew what to look for. You knew what mistakes to look out for. So you could do that quite efficiently using AI. But if you'd just gone in to begin with and it started telling you that actually there's all these job listings and you didn't like cross-reference that with anything, it's possible you might have got a completely different result. And without having done both of those stages, you wouldn't have known like whether it was correct or not.
You've seen AI generated video, right?
I probably have without knowing it, but yeah.
If you go, so OpenAI's model is called Sora. And if you go to the web page associated with Sora, they show demos. And their demos contain odd glitches. Like there's a woman walking in Japan and her legs are going back and forth like this. And then as her right leg is coming forward, her left leg goes forward. Like it skips like that. I got this pro account, so I was experimenting with it, and I asked Sora to generate a video of a finance professional who's trying to decide whether he's going to learn SQL or Python. And it generated this video that was extremely lifelike, except this guy is sitting at a desk, and he's looking up and he's thinking, and then he goes to his computer like this, and one of his eyes is like a lazy eye, and then it goes, it's a very subtle, but also, if anybody's watching that video, they're going to see, ooh, that's not quite right. What's wrong with that? And that's the subtle mistake. Behind him, there's a whiteboard, and it says in handwriting, Python, QL, SQL, question mark. And so then I told Sora, the model, change the text on this whiteboard to Python or SQL. I gave it very specific instruction. And it regenerated the video. And this time, the guy sitting at the table has this big, weird-looking nose. And the text on the whiteboard has changed, but it's like some other nonsense. It's like,
I mean, to me, it's like it's absolutely incredible that it can even get that far, that it can, produce these images and videos.
Yeah, it's amazing.
There's no kind of getting away from the fact that the technology is amazing. But I think we also have to remember that at the moment, these are just, they're large statistical models.
Yes.
And they're nothing more. So we can't expect them to do the sort of reasoning and thinking and certainly from the creative side, that kind of stuff, which we might expect a team of humans to do.
Because the statistical model is trained with superficial data. In the case of the video, it's trained like it's statistically analyzing the pixels of frames of videos. It doesn't understand this is a man and he has two eyeballs and like they usually move together when he's healthy. It's like, oh, I've seen videos where like an eyeball turns in this way. I've seen videos where an eyeball doesn't. And so what's the problem with putting both of those into a single video? Like it doesn't have underlying understanding. It's not making reference to underlying principles. It's making reference to the most superficial artifacts.
I guess what's interesting is that you could go out and hire an actor to do that and create that scene, and you might choose to hire an actor that has a lazy eye or has the ability to move their eyes independently. But at that point, it's a choice. You're choosing as the director of the video to do that. Whereas at the moment, the AI is just doing that, because of, I suppose, just statistically that's how it works.
Here's why I bring the video up. Essentially, the same technology that's generating this video with these wacky errors is the same model that's generating the text that comes out of ChatGPT. The difference is that when the text output has a lazy eye, it's not so obvious, but it's still in there.
Well, particularly when you're dealing with code, like if you're asking ChatGPT to generate like loads and loads of code, but you don't know that language, like the visual language of what a person looks like, so you can spot those things more easily, which I guess is exactly what you're saying. Whereas if you're given pages and pages of code and you're like, oh, computer code, like minimize that, just run it, then you've kind of got no hope of getting, or if you do get something that's useful out of that, you're lucky. And if you're just running it assuming that it's going to be the right thing, then you're kind of asking for trouble at the moment.
I think it's always going to be that way to some degree, because the way that we perceive the world, it's impossible for us to perceive the world apart from a goal. We perceive the world as in terms of affordances and obstacles relative to a goal. And here's what I mean. I have a little nephew. He's just about, is he 2? Yeah, he's just about 2. And his favorite things are balls. It's his favorite word every time he sees me. Ball, he wants to play. When he was younger, he was once in my house. I was carrying him through my kitchen. We walked past a basket of fruit, and he pointed to an apple, and he said, ball. perfectly reasonable generalization. It is right. It is exactly the same shape as a ball, but it's not. It's something different. But to him, that's a ball.
Yeah.
Same thing. He looks at this globe. I don't know how well you can see it. He looks at this globe back here and he calls it a ball.
Yeah.
Yeah, it is. Right. He didn't know apple. I actually, when he did that, I said, no, this is an apple. I took it and I bit into it. And then he started crying. And I don't know, but I wonder if that's because that's not what you do with a ball.
Yeah. There's that whole, have you seen this website? I can't remember what it's called now, but it's like things that my child is crying about.
No.
And it's this guy who's like documented all the things his toddler is crying about. And it's like, you know, one is like, oh, because I cut the sandwich wrong. And it's just, it's funny. But I think where we are with AI is like, you know, I'm not very reluctant to say that, you know, we're not going to get there, because if you look at the progress that's been made in the last, you know, 2 years or even 6 months, it's just the pace of development is kind of astonishing. And so, you know, I think it's entirely possible that we could get to a point where, you know, people are working on AGI and they do produce tools which are completely different from the current LLMs, but do have the same level of like reasoning and problem solving and things that people are trying to use the current generation of LLMs for.
Well, I agree with you that the pace of change is dramatic and amazing, but I don't think that we will ever get there. And here's why. It's because we can't make distinctions apart from a goal, and because AI models can't target the highest good. They can only optimize for proxies of goodness. So my little nephew eventually ate an apple for himself, and he realized that he liked them. And now apple is another one of his favorite words. He clearly knows the difference between a ball and an apple. Why? Because when he tasted it, he realized he liked it. And so then later he had the goal of wanting that thing that I tasted. And all of a sudden the distinction between an apple and a ball becomes relevant in light of the goal. The word apple, like the distinction between apples and balls, becomes an affordance that allows him to move toward a goal. Now all of a sudden he can ask for what he wants, and then he gets it more often. Machine learning algorithms minimize an error function. So I'm going to optimize predicting. I made a model that was used to predict liquidity. We used it to advise treasurers on how much liquidity that they should maintain on their balance sheet and with their line of credit. That model was basically, well, it was a sophisticated regression. And it iterated and iterated using brute computation to minimize the error of its predictions across a data set. But I can't design a model that optimizes for doing the right thing. Like, I have to give it a metric.
Yeah, and I think what you're saying is for kind of us, that's through learned experience, which an AI model doesn't have.
Well, and it's different. It's like there's something. Well, okay, we live in reality. This place exists. Like, I really am here. We notice patterns. Like, there are patterns in this place, even though every moment is different than every other. Like, your life is completely different from my life, and yet there's so many similarities that we can have a conversation for 2 hours and relate to common experiences. Like, you've never built the programs I've built in Python. I've never built the programs you've built in Python. But we can talk about Python because there are patterns. We can talk about apples. We can talk about kids. And a guy can make a website that people like to go to because they've all had common experiences. I can read Aristotle, who is writing in ancient Greek in 350 BC, and I know what he's talking about because the principles that he observed and represented with his words were general enough that they're still completely relevant to me in 2025 in America speaking modern English. So underneath all of these patterns, there's some ground of reality that determines what is and what is not. We could say our universe is governed by logic. Like, well, there's some process. Okay, go ahead.
I think what you're saying is kind of we all have the same frame of reference, which I think is right, because we all have the experience of being a human in the world. So we all have these kind of, not the same, but sometimes similar experiences. We all like have the same senses, we all perceive the same types of things, and we all have grown up in communities around us. And so that's what kind of now allows us to communicate between each other. Even, like people from centuries ago would have similar types of experience. So we all have that kind of shared frame of reference. But whether that's the same as like the reality of the physical world, we're sort of getting more into philosophy, I suppose, now, is for me a slightly different question. And because I sort of wonder, like, if we could speak to animals, we have like a language problem. You can't understand if, for example, if lions have language, which I know is probably not because they just roar. But if they did, it's not just a translation problem of being able to roar the right things and have the lion understand you. It's having that frame of reference. So if you were able to ask the lion, like, why do you do that? I'm not sure that they would be able to give an answer which we would make sense of, because their frame of reference is so different.
If we wanted to understand how lions think, like what it's like to be a lion, I could watch a lion to see what it moves toward, like what is motivating to a lion, like food, for example, but other things also. And then I would be able to test whether or not a lion distinguishes one signal from another or one phenomenon from another. Like, we use rats in behavioral experiments. We motivate them. We show them that, like, the goal that you want is in this direction. And then we watch to see how they behave in order to achieve that goal. And I think observing their behavior gives us a decent idea of how they're thinking. Like, maybe not what does it feel like to be in the body of a rat, but we can at least see, like, the rat can make a distinction. Well, I could test to see if a dog is colorblind. I give a dog food. I associate food with like a symbol, and then I put that symbol in green against a red background, or I put it in like white against a black background. And I see, does the dog go through the right door? If the dog does, I know that the dog associates the reward of the food with the symbol. So if the dog doesn't go through the door that's a green symbol or a red symbol on a green background, but he will go through the door with a white symbol on a black background, and that's because he's colorblind. He's not perceiving the signal.
You can, but I think I'm forgetting what point we were straying away from.
Well, okay, yeah, you're right. I'm allowing myself to diverge because I don't know. We're in bonus time, and I'm just curious to know what you think about this. But
I think because we were talking about AI, and can it ever get to that point of having that sort of sense of used? I think you said something about the sense of like of good or what's right or that kind of thing, and can AI like ever have that kind of driving motivation? Yeah, I guess I was just saying, we were talking about AI having motivating factors and, minimizing an error function, that kind of stuff, whereas humans are striving towards more complex goals. And I think you mentioned something about humans having a sense of kind of, what's good or what's right, that kind of thing. But really that construct, the sort of morality of that driving force for most humans is, I think it's not really proven whether it's something that's innate in humans or whether it's a social construct or whether there's...
We could say it's at least biological. Like, morality aligns with what we must do in order to persist. Like, it's wrong for me to go around and kill all my neighbors' kids. And I could give a higher level, like, I don't mean to reduce murder only to like a biologically ineffective behavior, but if a society rewarded people for going around and murdering their neighbors' kids, that society would not exist.
But I guess that was maybe in the back of my mind why I sort of brought in the example of the lion, because that has a completely different frame of reference where it needs to go around killing things in order to survive. So for the lion, like, that behavior is good.
Nobody would call a lion a murderer because it kills a gazelle.
No, but because that's kind of its nature. And so to sort of bring it back to AI, like, if you have AI has, at the moment we're training it on, minimizing some error function. But does that mean that in the future we couldn't have more complex sets of outputs that it's optimizing for, or even are there other ways of building AI models which are not in that sort of statistical mindset that we have for the current LLMs, that are really just regression models with a lot of complexity added? Are there other ways of building AI models that have encoded in them these different motivating factors?
Well, I would say you have to have one ultimate value. Like, if you're going to have a model optimized for something, like a model can't optimize for two things. It can only optimize for one thing. So you have to choose the thing that it's optimizing for. And then you can design the function that causes that value to increase or decrease.
But I think that's still like thinking about this regression type model. There was an interesting project called OpenWorm, which I think is still going. But it was a bunch of scientists basically, rather than looking at the behavior of a nematode worm and saying, okay, well, when we put food here, it kind of wiggles towards it or whatever, so build a model that minimizes the error between our virtual worm and the real worm. They started looking at the kind of building blocks and saying, okay, well, how do the chemical processes that go on in this worm work? How does the the hydrostatic pressure of the structure of the worm work? How can we code that up from like this bottom-up principle?
And so we're really modeling the chemistry.
And can they build something which virtually like has the same emergent behavior that would be recognizable as a worm? And I think that's like an incredibly interesting experiment. And after this call, I'm going to see if I can find it and see how they're getting on with it, because it's the opposite way of looking at things from the current AI, where we are just doing that thing of saying, okay, well, this is the behavior, this is what we want. So can we like
copy that superficially?
Yeah.
Right.
So I guess when I was saying like, I'm not going to rule these things out or like make any bets about what's around the corner, because I think there are so many different ways that these things could go that are just beyond what we're seeing with LLMs right now.
Well, we'll see. All right, Tony. Thank you for
as long as we
this
don't
time
end
with
up,
me.
Living in Terminator 2.
Yeah, we'll see. It's definitely going to change a lot during our lifetime, so we're going to have an interesting show to watch, and it'll be especially interesting being involved in technology ourselves.
No, 100%.
So, thanks for taking the time. It was a good conversation. I'm glad that we got a chance to talk about the things that we got to talk about. That's all for today's podcast. Hopefully you enjoyed the conversation. If so, please give the video a like. And if you want to see more, subscribe, and I'll see you in the next one.